Here we have a desk lamp. Actually feels quite heavy duty. So we have LED lights here. This slots into this here. We have a little thing here, I presume is for brightness. Well, we have one for brightness and then we have one for color. It looks like it goes from cold light to warm white. And we have this nice big clamp that feels very heavy duty. So that clamps onto here and then you would clamp that onto your desk. These can be rotated around, so you can have them like horizontal, like so. Now, when you plug it in, I don't suffer from epilepsy. If you do, maybe look away. It really does flicker so badly and it's so bright, it's actually hard to see. So be careful. Plugging it in now. Look at that. That's a lot brighter in person than it looks through the camera. When I look through the camera, it's bearable. When I look in real life, it's one of those things, it's like when you look at the sun, you look away and you can still see the sun. But if you have a look here, nothing's changing when I do this. When I do this button, or this button, nothing's happening. So let's bring it over the desk and find out what's going on. It is powered via normal USB. So we've got a normal USB here. And then this is, where does that go? That then goes into here. So it might be a problem here, or it might be a problem with the light itself. I don't know if there's any electronics, or is this just simply wires coming down. I'll tell you what we'll do, just in case. Let's plug the USB in this way, just in case it makes a difference. I know it shouldn't. And now let's plug this in. See, it could be the power supply that's pulsing. There you go, it's still doing it. So it's not that. So I think what we need to do is we need to get some kind of amp meter on here and see if it's the power supply which is doing that, or whether it's something in here. Should be interesting. Now, let's plug in this and see what happens when... Oh, hold on. So this is a USB-C going into here. Right, okay, no problem. Let's plug it into here and see what it's doing. I wonder whether we'll see this kick in and out. If this is steady, that says to me that the power supply is probably going to be all right. It says here it is a class 2 power supply. I'm not going to lie, I don't know what that means. I don't think I've come across that before. And it is outputting 12 volt DC 2 amps, and it is center pin positive. Let's plug it in and let's see what's happening here. Oh, look at that. There you go. 13 volts. 3 volts. It's the power supply. I bet you it's the power supply. Oh, no. Yes, that's not stable, is it? Now it's climbing. 10, 11, 12, 13, 14, 15. What? Down to 4. So we can see that nothing to do here. Look at this. Ah, it's a power supply. Ah, annoying. Let's see if it can come apart. Well, we know now there's probably nothing wrong with this, unless of course there's 2 faults. Can you come apart? No, of course you can't, because you're sealed. I wonder, is there any chance of a screw being under here? So it's just going to need a new one of these. It would be nice to know what failed on it. Let's see if there's any way I can open this. Just going to give it a few little taps to see if that will break any glue. Well, it's not wanting to come apart. I will be able to get into it, but I don't think I'll be able to put it back together. But it might still be interesting to see what's failed on it. Obviously, you shouldn't really be messing with power supplies like this because they are dangerous. And again, I could never sell this on because if I fix this, then it's just going to look a mess with all the glue. But you would probably be able to buy a 12 volt one 2 amp terminating in a USB-C. So you can see I'm in there now. But are you going to come? Oh, you might come apart, you know. Oh, look at that. That was very nice indeed, because it actually, it hasn't snapped. It's broken the glue on that bit. That was good. Look at that. So if I can get in here now, I've got to be careful because the main capacitor might still have charge, but I don't think it will have, because you know, the voltage was fluctuating, so it's kind of working. So hopefully it has bled itself down. Still got to be careful though, because I've got, this is all metal. Now if I could just break this as it goes along, we might have a chance of getting this back together. Here we go. Come on. It's just this bottom bit now. If I can get the bottom bit off without causing the same damage as here, 100% if I can fix this, I'll be able to get this back on properly. It's just this bit here needs to come off. Yes. No way. Look at that. The only damage was this corner bit here where I hammered this in. Look at that. I've even got the pins still okay here and here. Right, so the mains is coming in here. So I'm hoping if I pry here, I might not electrocute myself. I'm pretty sure that the main caps are going to be drained. Yes. There we go. They're just soldered on there. Haha. Bridge rectifier there. Where's the main chip? First of all, let's check these big caps because they're 400 volt. So I'm going to go across these here. So let's go across them, see what we have. 5.8 volts. 5.7 volts. So I'm happy to work on that. I think that's a massive diode. Where's the main? Where's the main chip? Oh, is it this thing? It's this thing here. There's a chip here. Right, okay, how am I going to do this now? So we know the fuse is all right. Could it be that the output capacitors are playing up? Should we see if we've got a short somewhere on the output? Maybe there's a short and it keeps restarting itself, but I don't know why it grows. No? There's no short on the output. Oh, I don't know how to fault find this. I think the main chip seems to be starting and stopping, starting and stopping. I presume there's no short on the wires going up here. No. Let's get rid of this mess. So we have got a massive diode here. Should we measure the diode in case there's a problem with the diode? Because I presume that's going to be some sort of rectifier diode after the transformer, and that goes into the positive side of the caps. Right, nothing there. No, I think that's all right. It's climbing, which I haven't seen before, but that must be to do with the voltage. It must be somehow charging up the caps. Let's try this diode here. Nothing that way. Good news is the board's lovely and easy to work on because it's not full of conformal coating. That's okay. Let's try this one here. Nothing that way. And then reading that way. So those three diodes are okay. Should we zoom in and check the resistors? Also, we've got a big capacitor here. Let's just check the caps for shorts. No. Bridge rectifier here, I presume, must be okay. Unless, could the main filter caps have failed? And they're charging and discharging or something? No. No, I think that's alright. Should we zoom in and check resistors? And there's not that much on the board. I think it's going to be this chip here. Maybe we should check this chip to see if there's any burn holes on it. Also, that capacitor is going to be used to start this chip up, I think, like a... It's called a bootstrap startup capacitor. I think the chip doesn't appear to be burnt. Let's check for shorts on this cap. That's in the mega ohms, I'm sure that's alright. Okay, I'm going to just be on resistance here. Let's zoom in and I'll read out each of the resistance of the resistors. But they are in circuits, they might be reading differently. So I check each of the resistors, and as far as I can see, they're all okay. They're either reading the value or they don't seem a million miles off. When they're in circuit, you will often get a different resistance reading. So the next thing I'm going to look at is that startup capacitor, you know, the little capacitor that gets the power to the chip, because the chip is the brains behind the operation, the chip on the top of the board that I couldn't find earlier. And if the startup capacitor isn't working properly, maybe it's giving voltage, then stopping, giving voltage, stopping. And maybe that's why we're seeing the power climb, drop. It's very strange. I haven't come across that fault before. But anyway, we're going to take the startup capacitor out of circuit to see if it's testing okay. So I do take out the tiny little cap, and it's testing okay for ESR and also for capacitance. But I have one of them, so I just put in a new one to see if it makes any difference, and it doesn't. But then I have a little look closer at the circuit board, and I spot this. I was just looking around this chip here, and what do you see when you see the back of this board here? So we know that these 4 pins are the chip, and so the other 4 pins, although we have holes here, are coming up here. But look at that. That's just punched straight through the board there. And I thought, ooh, was there supposed to be a via? Because normally you would have a circle here. So I got my hopes up. And then I looked up this chip here. And if I put some isopropyl on it, you'll be able to hopefully read it. There you go. SDH 8635. Now it wasn't that easy to find, but I just went to Google Images and I pulled up this one here, and you can see here that it's got the chip. Now I can see that there's a little notch on the chip here at the top, so that's going to denote pin 1, which is this one here. So we're reading it this way here, and then what do you see? NC is not connected anyway, so if we turn it round, that is that one. Yeah, so NC is this pin here, turn it round, which is this pin here. So it's not going anywhere. But I did notice that this one says feedback, which is opposite. So this pin here is the feedback one, and it does seem like a feedback problem, doesn't it? And that goes up here, and it goes to the opto-isolator. But look, there is a little hidden capacitor that was underneath the gloop just here, but there's no shorts across there. So it doesn't look great with the leg being punched right through, but unfortunately for me, it is a no connect. So it's not connected, so it's not doing anything anyway. Later on in the video, not this bit, but later, I do off camera pull the leg completely out of the board, just in case it's kind of giving some weird signals. But yeah, that leg's a no connect, so it's not making any difference anyway. But luckily, I do see something that doesn't look right. Check out this little transistor thing here. And the transistor does appear to be connected somehow to the feedback circuit. Oh, so messy. Right, there is a transistor here, and the transistor does feed the optocoupler. So let's go to diode test just to see if we have any weird short or something on that. No reading there. No reading there. Swap the leads over. Reading. Oh, no reading there. I would have thought we would have had a reading there. So on this one, we don't have a reading either way. Interesting. Okay, let me go here. Oh, hold on. Ah, let me zoom right in. I want to have a look at that transistor. That doesn't seem right, because if you have a look at the optocoupler here, which we know is to do with feedback, and this does seem like a feedback problem. The optocoupler goes to the feedback pin here, I think it was. No, sorry, here. So because it goes up, I can't even see where it goes now. Up along here, there you go, here to here, around here to here. So that's one of the pins here. Now look at this side. We have one leg going round to here. So if I go to continuity, this one goes to here. Yeah. And this one goes to there. So this leg, I don't think appears to be doing anything. And you can see it goes to here, but it also goes to here, which then goes through here and goes up to here, which then goes through the coil, which then goes to the red lead here. Now where's the negatives? So negatives are here. So that's a negative there. Maybe this, maybe it's not a transistor. Maybe we have negative here, either the voltage in here, or voltage in here, sorry, do you know what it probably is? Voltage in here, and then maybe a different voltage to feed this here. So I looked very closely at this transistor, and luckily for me it's got markings on, and then I Google those markings and I'll read out what it says. There is quite a few bits cut from this video. I have also taken away the USB-C cable, just in case that was putting a fault on, and just put my own leads on it. It just makes it easier for me to test with my multimeter rather than relying on the USB-C amp meter. So there might be some parts of the video where you think, oh, there's a blob of solder there I don't recognise, or suddenly the leads are different. This video was very, very long, and I'm having to edit it very heavily to get it any bit watchable. So I just typed in 431KE. I know it's not a transistor, but I typed in that, and this is AI. It says the 431 in 431KE transistor likely refers to the TL431 KIA431, a programmable Zener diode with a 3-pin package resembling a transistor used for adjustable voltage regulation. It's not a transistor, but acts like one in power supplies, providing an adjustable output voltage between 2.5 and 3.6 volts by using external resistors connected to a reference pin. So now, we know one of the pins weren't doing anything. And I know all the resistors are testing okay because I've tested them. So I'm wondering whether this has failed, and it's varying because it can change the voltage from 2.5 to 36 volts by using resistors. So if that's the case, maybe then if it's failed, it might be unstable. So these things really are dirt cheap. They're almost pennies if you were to get them from AliExpress. I have to pay a little bit more from eBay, but we're still talking 20 or 30p each, not a huge amount of money. Obviously when you buy like 10 or more. Now, I did order some up from eBay, and then I was doing another fix on something else, and I had to look for transistors, and I got a transistor kit from eBay years ago that came from China, and I couldn't believe it. I was looking through there for, I think, a PMP at the time, and sure enough, there was a little bag of components that said 431. So, although I've ordered them up from eBay, I don't have to wait for them to arrive. So let's pick this up now in a few days' time when I discovered that I actually already owned these chips, which is a bit annoying. TL431A. I'm going to take out one now, and I want to see if we have diode reading on both of the pins from the top pin. If we do, we know it's behaving differently, even though this one isn't out of circuit, than this one here. So I'm hoping that this one will test differently, and then we've proved the fault onto this, because this is to do with the feedback. And we know it's a feedback problem because it's just all over the place. Right, okay, now look at this. So we're on about this little transistor here, but it's not a transistor. Watch this. If I do red lead to the top one here and go on to here, we don't have anything. Sorry, we've got something there, but we don't have anything here. And then if I swap the leads around, we don't have anything here, and we don't have anything here. And then if I go here or here, there's nothing. So the only thing we have is between here and here. We haven't got anything on this leg here. And this is the reference one, getting the reference voltage from here. Now, please, please, please behave the same on here. Sorry, behave differently. So we should have something between here and here. We have, please have something here. There we go. Did you see that? So 100% we found the faulty component. I think this little power supply is going to work now. That's so good. Look at that. Amazing. Right, let me go on these two. Don't have anything there. Swap the leads around. We got something there. It's testing completely different than the one I've got in circuit at the moment. So I think we have finally found our problem. Yes, it's in circuit, but I think we found it. There we go. A little bit of flux on. Now we're going to put this on with the soldering iron. Beautiful. Right, multimeter time again, and now it's in circuit. I'm hoping, I'm praying, it's going to be the same as it was when it was out. So we now have a reading here. Please have a reading here. Fantastic. There we go. Proof that this is behaving differently than the last one. Oh, amazing. Now it's time to plug this in and see if we have a more stable voltage. So again, I'm keeping my hands well clear. That's still attached there. That's attached here. And let's get the extension lead. Right, so plugged in, and now is this all safe? I think so. Right, I'm going to plug it in now. You ready? Please don't go bang. We're in. Hands well away. Oh, amazing. 12 volts, not even 18. Yes, yes, yes. 12 volts, not even 18. Oh, that's amazing. And it's just, look at that. Rock solid. It was a feedback problem. Now, lots of you lot knew that. I'm unplugged. I didn't know that. Let's see how quickly it drains. I didn't know that. I will never, never, never forget about this thing now. This is just fantastic. Look at that. It's still here now. You've got to be so careful. I've been unplugged about a good 20 seconds or so. So it shows you the voltage that's left in those big caps there. Look at that, it's still going, still. If I come across that again and I have fluctuation voltage like that, I really do need to look into the feedback side. But this is what comes when you do more and more power supplies. Like, lots of people are scared to work on power supplies, quite rightly so. Also, most people be like, why is it even worth working on this when you can just buy a new one? But for me, I'm starting to learn a little bit. You know, to begin with, I didn't even know about bridge rectifiers or anything, but now I'm starting to understand a bit more. And today, I have learned a bit about the feedback circuit. So, yeah, that's so good. Oh, that's honestly, that's so good. Right, I'm going to solder the proper lead back on, and do you know what I'm going to do? I'm also going to put the original capacitor back in. Not because they're expensive, just purely because that way then, the only thing we've changed in the power supply is the actual, that little component there. You can see the voltage is near enough gone now, so I presume the voltage on the big cap has nearly gone. 6 volts, yeah. That's amazing. Did you see how rock solid it was? That's so good.
So I solder in the original capacitor, not because they cost much money, just purely because I like to have it where it's completely original, apart from the one thing that fixed it, rather than changing 10 different components. It's just the one thing that got it working. I love it when something small has caused the whole thing to fail. And then I need to put on the original USB-C lead. I need to glue this all up properly, but just for the time being, for my testing, I'm just going to wrap some sellotape around it, because gluing it up is going to take a little bit of time. But look what happens when we plug this into the rest of the light. You would expect it now to work. We found a fault, but obviously I've hinted many times, because I've heavily edited this video, that this isn't the only thing wrong with this desktop light.
Right, here we go. I'm going to plug this in now. We're in. Let's plug this into here. And nothing happening. So now something clearly has blown in here, because before we were getting a flashing light, but that's probably because it was going all the way up to 18 volts. Oh. Right, let's take this apart now and see maybe what's wrong with this. Actually, let's do this. Where's my ammeter? Let me just see now, is it stable? Remember it was flicking before? Yeah, look at that, 12.3. So let's plug this into here and see if it's doing anything. No, just drawing a tiny little bit, 40 milliamps. Now let's fault find this. I presume there's going to be some sort of screws underneath here. Wow, I went to the right place straight away. Here we go. I think this has to come off. Oh dearie me. Oh wow. Ah, this looks complicated. Holy moly, this is even worse than the power supply. What would be nice is if there's a fuse from here which has gone. But when we plugged it in, it did have 18 volts. Remember, it was flashing, so I presume the fuse is going to be okay. So what's happening here? We've got would these two be? Oh, it's just here and here, isn't it? Here, and then this one and this one, which are linked. So I'm thinking that's going to be negative. Let's have a look. So that's negative, and this is positive. Oh, we got a short, have we? No. Right, first of all, have we got anything through here? I don't think so. Is that 810? Or 018? I presume it's 810. Is that like the main fuse? $16 volts. Is that really burnt? Is that badly burnt there? That don't look clever, does it? I think this is our problem here. So where does that come from? Is that from here? Or maybe this is the main one in. That's also a 01. No, that's a different one, 01C. Anyway, if that is the main pin, which it could be, maybe we've got 18 volts there, then does that go to here? I mean, that looks awful. Let's give that a clean up. Where does that come from? There. Resistor 4. Where is that supposed to go to? Is this the input letter? Is that there? Is that there? I wonder where that one goes. Oh, to the middle pin here. Well, this is some kind of voltage regulator. And I don't think it's getting there. Let's zoom out and we'll get an ohms reading. hopefully we're not going to have anything on the burnt resistor. How annoying, we do. 240 ohms. Just doesn't look correct though. Well, I'll tell you what we'll do. Let's put voltage in and let's see what we're getting on this voltage regulator here. So I don't think that's working. I presume that leg is ground here. Yes, and that one is going to be there, and then this one goes off to that capacitor there. Let's get voltage in and measure voltage. Now let's go down to, do we have anything on this leg here? I don't think that's right, 0.9 of a volt. Let's see what we got on this side of the resistor. We've got 12 volts there. I think we should have 12 volts here, and then we're going to have maybe 5 volts coming out here, but we haven't got anything here. I do think that resistor's gone. So we should have 12 volts there. Yeah, I don't think that's right. Let's zoom right in on the resistor and see if we can work out what the reading is on it. Right, unfortunately it's burnt. You can see it's burnt right in the middle there. So I can't see what it's supposed to be, but I think that is, let's have a look at these ones. Could it be a C1? Now that looks like an A at the end, does it not? I've got zero idea of what that could be. Okay, you know what I think it might be? There's an EIA 96 resistor readings where you have letters involved as well if it wasn't already complicated enough. And if you have a look here, it could well be that, couldn't it? O1A. Because O1A. I think it's an O1A, 100 ohm.
So I find myself a 100 ohm little SMD resistor. That's 101, which is 10 plus 10, which is 100. And I pop it in, and then of course I make the joints as good as I possibly can. And now we're going to see what voltage we have on the right hand side of the resistor going into the voltage regulator.
You ready? Plugging it in now. Right, what are you going to be here now? So we've got 3 volts going in. That's not enough, is it? Nothing coming out because the oh no, sorry, this is the chip coming out here. 2.5 out. Okay, so clearly it's not 100 ohms. It's not 100 ohms. I'm thinking just putting 12 ohms in will probably be fine. Otherwise I'm going to be all day, aren't I? Okay, I'm going to take that one out and I'm just going to put a 10 ohm in. So if you have a look at this one, this is 100. So 10 and 0 zeros, which is just 10. I'm just going to use some hot air on this to make it easier for myself. Pointing it away from that cap. I'm going to put some blue tack on this because it's moving around lots. So my thinking is, if I know this isn't, well, maybe there is some sort of voltage divider and this goes off to another resistor down to a ground. It just doesn't seem to be. But my thinking is that if 12 volts went to 3 volts on 100 ohms, maybe 12 volts will go to maybe 8 volts on 10 ohms. But I have zero idea.
And this little chip above it is a 5 volt voltage regulator, and I think the input can go all the way up to 30 volts. So it will accept a wide range of inputs and it will still output 5 volts. But remember before, it was only 3 volts, so we're not going to be able to get 3 volts in to put 5 volts out. It has to be higher than 5 to get the 5 volts out.
Right, so now if we go to here, to for example that side of the cap, you can see we've got 10 ohms now. Should we plug it in and see what we have? Come on now. please work. No, 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 no. I've just seen smoke come out. Oh, come on, Vince. It's red hot. Or is that hot because of... No, that's because I've just heated up the board. Did I see smoke come out? I thought I seen smoke come out. Hold on. I'll tell you what we'll do. Let's plug this in and see if it suddenly goes really high. Maybe I didn't see smoke come out. Definitely seems to be doing more. £10 going in. 1.2 volts going out. What? How's that possible? Should be 5 volts going out. We've got 10 volts going in. Oh, come on, Vince. I think something might be dragging it down. Because if you have a look here, on the output of that, eight ohms to ground. I think what's happening is, I think this is heating up. No, unless the chips failed internally. Hold on a minute. Let's just go to ohms. Maybe the chips failed internally. 8 ohms doesn't seem right. I'm going to pop that off. I don't know, is it something on here which is causing it? For example, has that cap gone, but it's not a direct short? Or is it is something failed in there internally? I'm going to pop that off.
I'm taking off the voltage regulator because we've got a good amount of voltage feeding it. I think, was it 10 volts? And it can go up to 30 volts because I looked up the data sheet of this voltage regulator and it should be outputting 5 volts. So if we've got 10 volts going in, we should definitely be getting 5 volts out. But we're only getting 1.2. Clearly not right. And we have 8 ohms on that output. It doesn't seem correct. So I'm taking off the voltage regulator because now I've got to hunt down this 8 ohm short. But an 8 ohm short's quite hard to hunt down because it's 8 ohms. It's not direct. If it was a direct short, it's going to be a lot easier to find if you put in voltage injection rather than an 8 ohm short. So for all I know, 8 ohms might be correct. It's actually quite high, but it doesn't seem right. But I haven't got another one to compare. So I'm popping the voltage regulator off to see if that clears the 8 ohm short that I think shouldn't be there, but I don't actually know.
Yeah, it's not that. There's something dragging that down, I think. So there's nothing there now. But if you have a look here on that cap, we've still got 8 ohms. And on that first leg off the chip, I think we've probably got a failed chip. And annoyingly, that chip has no markings on it. This one here. Right, let's take the cap out.
So although I do think it is the chip, it's easy for me to take the cap off. I don't think the cap would fail with an 8 ohm short, while a chip might do. But the cap's a very easy one to eliminate, so let's slide it off one of the pads and then we can see if the 8 ohm short is still on the pads. It'd be amazing if it was the cap.
Just going on the pads. Nope. It's going to be the chip, I'm sure of it. Right, I'm going to take that chip off. And I might as well put the cap back on. I'd love it if it was still there. No. Right, okay, let's find out which one is ground. So this pin here is ground. So I think if we go between here and here, we're going to find the 8 ohm short. Yeah, there you go. That shouldn't be there. So now I am going to put this back on here, and I bet we find that we have got 5 volts go into that first pin there. And what's happening is the chip, this chip here, is bringing that voltage down to 1.2 because maybe it's, well, I don't know, because it's like a short.
Such a shame because we come so far. Anyway, let's give a shout out to the My Maintenance Massive. The members this month are Keymon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeebs.com, DJ VG, Pigsy, Anthony Dean, Russ Mellinson, Rickard Bergland, Shamsa Al Sawadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, AJ Computer Services UK, and David Delay. As always, a massive thanks to each and every one of you.
Interestingly, there is a marking on the back of the chip, not the front, but the back. I've seen that before, where I've had different markings on the underneath than I have on top. Don't even know what that is. Part of me wonders if there's a way I can just jumper from here to here just to get the light working and forget about brightness and forget about the colour side of it. Alright, watch this now. When we plug it in, I bet we do have 5 volts. In and in, and if I go here and here, there you go, 4.9 volts. So you can see on that pin there we have 4.9, and there, that's the ground. So I think that's working fine. Do we have any abnormal heat? No, I'll show you that. It's heating up a bit because it's a voltage regulator. Oh, I don't know what to do now because I can't look up the data sheet off the chip. I mean, maybe... There you go. Can you see the hottest thing here now is this? Hottest thing is... this here, that chip. Oh, what a shame. You can see my mat's hot from where I've been heating.
Desperate times call for desperate measures.
Right, I'm doing stupid stuff now because I can't find what this chip is. But interestingly, I can get it where it can light up all the time. And I found 2 different colours. So we know that the 5 volts is coming into this bottom one. So if I use the tweezers here, and if I go between this one and the third one down from the top, you can see we have a lovely warm white. So blinding. There you go. Yeah. If I go one below that, we have cool white. So it's a lot whiter. So that's a nice yellow. And that's a nice white. Now, I wanted to see by putting this chip on. Interestingly, I just started filming now. When I did it, I thought a little green light came on. So I'm wondering, is there a way maybe I can disconnect the ground? Would we still have something? Because look, if I put it on, this is live now, so this is dodgy. But, you know, I can't really do much more anyway. When I put it here, I thought I seen, oops. I thought I'd seen it come alive a bit. Let's try moving everything up one. I thought when I did it, I seen it. There you go. Did you see it come on there for a second? I wonder if, let's disconnect this. If we were to take off the ground, would it somehow get the ground from elsewhere, but then not put the short on? So I'm just going to lift up the ground leg with my nail, like that. Let's put that back down. There he goes. It's interesting. Oh! I had a green light on before though. Only for a second. So I've got zero control over this. Oh, green light. Green light came on there for a second. So what's happening when I get the green light on? How about if I solder it back in apart from the ground leg and see what happens? Alright, so now it's on all the time, and when we press this, it goes off momentarily. Oh, that lights up when we do that. That's flickering. It's not changing brightness or anything. And then if we short that pin to ground, does it go off instantly? Yeah. Oh, there we go. Oh, it worked for a second. See that there? So, on. It's working. Down. And now, does this do, hold on, does this do colour? And that will do colour, I think. Yeah, that does colour. Right, what's going on? Is this putting a resistance, a different reading on it? Or do you reckon if I just put it down now, it will work? What on earth's going on? Let's try putting it down now. And I'll just use I somehow got my hopes up, but it doesn't make any sense because there was a short across that. Right, let's see now what you're going to do. Don't believe it. It's only working. So that's the brightness one. And then if we do this one, it changes to colour. White and warm. What's going on, Vince? What voltage have we got there now? What is going on? Well, mind you, voltage is different now because it's going to be on. Let's... getting confused. Five volts. Let's kill power a minute. Let's turn it off. Let's see, do I still have that weird ohm reading? No. Remember I had 8 ohms before? Remember across this resistor? So let's just make sure power's definitely gone from this. Right, now across the resistor, we've now got 116 ohms. We had 8 ohms there before. And across here to here, you've seen how I had 8 ohms. I even had 8 ohms when I had the chip out. Now 116. Somehow we've blown the short open. Could it be when I was moving the chip up and down that I shorted something? Could it be heat because I applied heat to it and that somehow fixed it? How bizarre. So now if we plug this in and we don't plug in the lights, you will see that no longer have we got it going down to, it's not bringing it down. Do you remember we've got on the middle pin here, whoops, 12 volts, 11.8, and on this pin now, we've now got 4.9. Remember it was 1 or something.
Well, there you have it, the wonderful but confusing world of electronics. How on earth did we have an 8 ohm short even when I took the chip off the board? It was 8 ohms on my blue mat, not connected to anything, and that's what was dragging down the 5 volts to about 1.2 volts. And now all of a sudden, by just sat on my blue mat, it started to work when I started wiggling it up and down the other pads. If you've got any idea what I did to fix this, please put it in the comment section below. I'm just going to put it down to a fluke, and maybe when I was wiggling it up and down on the other pads, somehow I blew some short on the inside of the chip and it's working now. Maybe there's something on this chip that's not working, but I don't realize. Maybe there's some kind of protection, something or other, on this chip that's no longer going to work. But unless there's a fault on the LEDs, I won't know about that. I really have zero idea. Anyway, the video's long enough. I'm going to put it all back together and then I'll show you it working. as an actual desk light. I'm going to clamp it onto my dining table, and you can see it working in all its glory.
Showtime at last.
Right, so I've glued it up. I didn't need to use a plastic bonder because when I put the epoxy around it and put it in the vise, it completely clamps shut, and you can't even see any break up there now because the break's under the plastic. So I think that's going to be fine to use. I wouldn't sell this one on, but that would be fine for me to use anyway. Right, let's plug it in and I'll show you this working. So you can see now you can put it in different directions. So this is flexible, and this you can flip down if you wanted it more that way or straight out. So that's now going to put the light down that way. I think the idea, if you have a look here, is to have like a monitor underneath it. A bit like a reading light that you would get over a bookcase type of thing. Now let's see if it's still working today. Yay! Fantastic. So if you have a look here, you can see the brightness will change when I go lower and higher. And let's see if you can see the colour change. No. Oh yeah, I can see the colour change now. I thought that would have made a difference on the table. It's not really coming out as much in the camera as it is with my own eyes. But there we have it. Personally, I always like the look of more warm. I think cold often looks like an operating theatre, but it's okay for bathrooms and kitchens. But I like the look of the more kind of incandescent. You know, it looks more warmer than the white. So I like that more than that. Well, there we have it. I quite like this light here. It actually feels like it's made relatively well, apart from what's going on here with the USBs. Let me know down in the comment section if that's completely wrong, because I don't think you should be using connectors like that when they haven't got the specified voltages that they're supposed to have. I found it particularly challenging, but I got there in the end. I think we can all agree a series of unusual faults. The power supply is probably quite a common fault. I've learned a lot, so if I come across that in the future, I think I'll be able to fix something like that a lot quicker next time. I found it interesting about the feedback little chip there. But the main thing that confused me here was that chip. Why did the chip start working? Because even when we took the chip out, it was still 8 ohm short between the live and the ground. Yet for some reason, when we put it back in, it then started to work. Really, really strange. I don't quite know what's happened there. But luckily it is working now, and hopefully it will continue to work. If you do have any info on that fault, put it down in the comment section below, because it will help me and also other people reading it. But somehow we managed to get that fixed and the power supply, and now we have a working light, which is fantastic. Thanks for watching everyone. I'll see you again very soon.